Okay, so here's the thing, guys. It is currently about 1:12 in the morning. Saturday. I have not had a chance to get to the video yet. I have worked through, I've completed everything, and I want to show you all the correct answers for it and how I got them, but I don't have the opportunity to go through all 49 slides kind of step by step right now. So, this is what I'm going to do. I'm going to show you guys what they are. Briefly talk about it. That's a lot of work here, so I want you guys doing your best and checking. So here we go. 1 and 2. What we're going to do is we are going to graph each of the lines. I did that by putting them into y equals mx plus b. Oops. And then you find the point of intersection. Do that again with number 2. Graph both lines. Find the point of intersection. And that's your answer. Again, with 3 and 4, graph, find the point, graph, find the point. Okay, so that's how you graph a system of equations. Now notice what I did on all of these is I went and put it into point or slope-intercept form. So 1, I think it's the easiest to graph from, and 2, it's the one that people are most familiar with. So, win-win. Okay, so now notice for 5 through 12, it's system of equations. You can do these by any way you want, really. Substitution and elimination are the most common. So here at number 5, where we have a negative 5x and a 5x, just add them up. Solve for y. Plug y back in. Solve for x. We get 1, 2. Number 6, we're going to add again. So that's called elimination, because when we add them together, we're eliminating one of them. Solve for y negative 4, plug it back in to either one of the equations. We get x equals negative 9. So our point there is negative 4. Number 7, same thing. Notice what I did here was I subtracted them. And that way, it changes the sign of everything inside of it. So we end up with x equals 4. Plug the 4 back in. Y equals 10. Again, I'm going to subtract the bottom one from the top one. That's going to allow me to eliminate y. I get x equals negative 1. Now notice here, I made a mistake. I'm not sure where my stylus went. Oh well. So it should be negative 1. That should be a positive 6. So I should be subtracting 6 from both sides to give me y equals negative 9. 1, negative 9. That's my answer. So, number 9. Now here, I'm going to have to multiply the bottom one by a negative 2. Now I could just do it by 2 and then subtract, but I like adding better. So I multiply it by negative 2, and that's going to give me negative 14x. Or positive 14x minus 12y equals a negative 42. Add those together, I get a negative 4y equals negative 28. Divide both sides by 4. I get a negative 7. Plug that back in. I get a 0.37. Same thing for number 10. I'm multiplying them by 2. Y equals 0. Plug the 0 back in. X equals negative 2. So my point is negative 2, 0. 11. Now 11 I have to multiply both of them. I'm going to multiply the top one by 4, bottom one by 5. That's going to allow me to get rid of my x's. I get y equals 1, plug it back in, and I get x equals 1, so that point is 1, 1. Number 12, same general idea. So on number 12, it's -2, -2. Again, check your work. Make sure you're doing it right. If you have any questions, come see me in AOT, which there's none of this week. Just so you know, I do have lunch duty. So there's that. So this is how. So here, the next one we have is a word problem. A plane traveled 760 miles each way to Miami and back. The trip there was with the wind. The trip back, therefore, was into the wind. If it took 5 hours heading back and 4 hours going there, what are the two speeds? So what we do is we set it up as 760 miles. 760 equals 4x plus 4y, and 760 equals 5x minus 5y, where x is the airspeed of the airplane, y is the wind speed. And then once you have those, you solve. So you're going to multiply the top one, I did by a -5, and the bottom one by 4. That is loud. Then we solve it out. We get y equals 18, plug it back in, and we get x equals 175. So airspeed was just checking my work here. So x is the plane speed, so that was 175, wind speed was 18. Okay, looking at number 14, a boat traveled 90 miles an hour. 90 miles there and back. Same general idea. 90 equals 6x plus y. 90 equals 10 times x minus y. Or 90 equals 6x plus 6y. And then it 10x minus 6y would be the, or minus 10y rather. So what we got to do here is multiply the top one by -5, bottom one by -3, or by 3. Add them up. And so we have 12 is the speed of the boat, 3 is the speed of the curtain. Same general idea for the next one. That's what it should look like. Okay, so this next one, oh dear. We're doing system of 3 variables. So what we do is we want to eliminate one first. Now notice that if we add the first and the third together, or the second and third together, the z just drops right out. But what also happens, or rather, because we have that 1 and 3, it's that -x. So that -2x is there, and it can instantaneously wipe out basically the entire equation. So we get z equals 3. Start plugging that back in because we're going to go 1. We're going to go 2 and 3, add together. So we get 2y equals negative 4, or y equals negative 2. So now that we have x, we have z and y, plug it back into one of the top equations, solve for x. And we get negative 4 and negative 2. So, 17 would look like that. And 18, apparently, I had some problems with. But that is what 18 should look like. $19. Okay, so for each of these next ones, what we want to do. So I couldn't see it very well in this, but what we want to do is we want to basically kind of sketch the graph and go. So I know y is greater than negative 1/2 x plus 1. So the reason that I immediately cancel out b and c is because I know that if the dotted line stands for greater than or less than, the solid line is greater than or equal to, less than or equal to. So notice that in my original problem I don't have any less than or equals to, so if there's a solid line in it, it's wrong. Those would be the answers, though. A for both of them. Sketching the graph of the function, what we want to do is find the vertex, find the 0 point, and then reflect that over the axis of symmetry. We did a bunch of these. If you're not sure how to do it, again, I don't have time and I don't want to have a 3-hour long video, so just come and make sure you know how to do it. But that is what the sketch of all those would look like. Moving on, solving by factoring. Now, we went over this a lot. So this is where you have to, you have simple factoring like 26, which is just what are the factors of 8 that add up to 6? And we go, okay, well that's 4 and 2. And then we set it up into binomials and we solve for 0. Same thing for number 27. Is a little bit tougher because now we have something in front of the n squared. So we multiply 7 and 40 together. And again, I don't have the time to go through and kind of reteach this right now. So if you're not sure how to do this, please come and see me. That is what number 28 would look like. This is 29. This is 30. $31. Okay, so then we're on to number 32, in which we are asked to complete the square. Again, this is something you should have in your notes for how to do this. But that is what 32 should look like. 33. 34. 35. 36. 37. And then 38, 39, and 40, we're going to use the quadratic formula, which looks like that. We're going to identify our A's and B's and C's, plug it in. So there we have, again, what we're doing is we're, with a quadratic, we are putting it into that formula. And there we go. Notice here that we end up with an imaginary root, or an imaginary answer. Again, if you're not sure how to do these, come by, see me, and I'll walk you through it. So next we use the discriminant to determine the number of real solutions. Remember, if the discriminant is positive, we have 2 solutions. If it's negative, we have 0 solutions. And if it's 0, we have 1 solution. The discriminant is the b squared minus 4ac that you see underneath the radical in the quadratic equation. So 41 is negative 144, 0 real solutions. 42, the discriminant's 81, that's positive, so we have 2 real solutions. That's 43, 44, 45, 46, 47, and 48. Again, if you're not getting these, feel free to go back, rewind, pause, whatever. So when we evaluate a function, what we're going to do is we're going to take that negative 10, and we're going to plug it in for our variables. So the value of the function at negative 10 is 90. And that's the rest of those. So on these ones, remember back at the beginning we had to figure out which system of inequalities matched up with what. Well, now we're actually going to do them ourselves. We graph the two, figure out where the overlaying is, and then shade that in. So here we're asked to write the slope-intercept form of each line. That's y equals mx plus b. Here it goes to the origin, so b is equal to 0. And the slope, we go down 3 over 4. So the slope is going to be negative 3/4. So y equals negative 3/4 x plus 0, or just negative 3/4 x. 58, same thing. We identify the y-intercept. The slope's negative 1. Plug it in. So 59 and 60. We're writing the slope-intercept form of the equation. So we just plug it in, like so. the slope-intercept form of the equation of the line. So what they're doing is they're giving it to us in point-slope, asking us to write it in slope-intercept. All we have to do is solve for y. That was a bit much. So that's what 61 would look like. It's not pretty, but that's how it's done. That's how 62 looks, a little bit prettier. So 63, we know that parallel slopes are identical and perpendicular slopes are negative reciprocals. So we have a point, and so we can write it in point slope, and then we can transfer that point slope into slope intercept. Like so. Like so. Like so. And finally that for 66. Now for 67, we're writing the standard form. So what we need is we need ax plus by equals c. So when we put into point slope, we get that. We're going to then get our variables on one side of the equation and the constant on the other. Like so. 71 on, we start doing operations with complex numbers. Now, the first ones, we really just treat it like a variable. Don't really need to do anything. If we have a negative outside of a parentheses, like we did in number 71, we distribute that. Other than that, we just make sure that our i's, that our imaginary portions of the complex number don't mix with the real portion. Now notice here, 75, 76, pretty much the same. And then 77 on, it changes. Now 77 through 80, we're going to FOIL these out. The problem here is that when we FOIL like 3i times 8i, we're going to get 24i squared. Remember, I squared is negative 1. So that's how 77 would look. 78, 79, 80. Now here what we're going to do on 81 and 82 is we need to rationalize the denominator. So 81 and 82 is pretty straightforward. We just multiply by I. That turns into I squared, which gives us a negative 1. And then the top, like so. So notice we multiply by I over I. That's 1. So we're not actually changing anything. Distribute the I to the numerator. The bottom becomes 6 times I squared. I squared is negative 1. 6 times negative 1 is negative 6. Same general idea for 82. Okay, so now 83, 84, pretty much the same. 85 on, we need to multiply by the conjugate of the denominator. Conjugate is what equals, it's the opposite of it. So when here we have 6 minus 5i, so we're going to multiply by 6 plus 5i. That's the conjugate. Now remember that when we're doing these, we want to put them in complex form, which is a plus bi. So we always want to separate them out like that. That's what 85 and 86 look like. And that's the last 4. Or that's 87, 88, 89. And that's 90. Okay, so that's all 8 pages of part 1. So let's go on to part 2. Now here we need to figure out whether or not it's a function. I'm not doing the domain and the range. So a function occurs when for every one x there's one y. Now you can have multiple x's have the same y, you just can't have multiple y's to the same x. So what we really want to do is check to see whether or not there's any repeating x's. For number 1, no repeating x's, so yes, it's a function. Number 2, notice that we have repeating x of 1. Now, if they have different y values for that one x, then we don't have a function. And there you go. So number 2 we are describing the transformation of the parent function. This is just kind of remembering how they work. Those are your answers. If you're not sure about any of them, come and let me know. There's number 5. Now, the next couple didn't actually show, so I don't have those done, the linear programming ones. But what I did do is, I'll show you how with the word problem. So, x is the number of hours that one chef baked, y is the number of hours that the other chef baked. So we have 2 equations. One is our tomato soup, the other one's, I forget what the other soup is. So 5x plus 4y equals greater than 50, because the potato soup or whatever it is, we need more than 50 quantities of it, and the first one can do 5 quantities of potato soup in an hour. The other one can do 4, so we know that that's our equation. That's the equation for the tomato soup. We know that their hours have to be greater than or equal to 0. So that's our potato soup line. We graph that using the y-intercepts because it's in standard form. That's our tomato soup line. And then the red lines are our x is greater than 0, y is greater than 0. So what I do now is we color in those portions which make everything true. That's our feasible region. That means that the answer to this question has to be in that area. So what we want to do is we want to label all the points of intersection between any of the lines. And then what we're going to do is we're going to plug each one of those missing pieces, or each one of those intersections, into an equation and see where we go from there. So the 0, 10, 10, 0 is pretty straightforward. What we had trouble with was so the difficulty here, sorry about that, the difficulty here is in finding this right here, that point of intersection. And for that, we use a system of equations, and we end up with 3.3, 8.6. So what we want to do now is we want to take each of those points, plug it into the equation the cost equation, $20x plus 22y, and see which gives us the lowest answer. So we're trying to minimize our cost. And when we do that, we see that it's this point right here, where Chef 1 has 10 hours and Chef 2's got bupkis. So I know it's not great, but hopefully this helps. If you have any questions, please let me know. Have a wonderful evening, everybody.